Hello, everybody. Good morning, good afternoon, and good evening to all of you who is watching us today. Uh, I'm Daniel, live from SolidCAM International Support Office here in Belgrade, in Serbia. And this time I have prepared for you a presentation about SolidCAM Toolkit. By my opinion, one of the biggest improvements done in SolidCAM 2021 release. And I will be pointing the features and tools that are available for the Milturn and Swiss type solution. And together with that, I will also talk about the newest features available in the SP3 just released version. So with that said, let's jump into our presentation. So let me go here and I'll start with something simple, or let me just hide myself in the moment. So basically, I will start with something simple. I will talk about basically the core of the toolkit, which actually consists of the three different libraries. On the very left, you can see the tool component library called, which is with the extensions of TLV. And basically here you can actually store all the tool components, okay? The holders, shanks, cutters, adapters, so everything. Store it in the folder, organize it in the folder. With that, you can all these elements put together in some kind of assembly with whole structure, everything connected, okay? The extension, when you are saving this, it's basically the TLS. And the final stage is basically creating the machine tool setup library where we can basically see the kinematic of the machine and really putting our tool assemblies into specific off station. Now, what I wanted to point it out here is that each of these libraries, they are connected, and changing anything in the tool components library will reflect later to the tool assemblies library, also machine tool setup library, okay? And this is what I actually like about the toolkit. Everything is connected, parameterized, and any changes, will reflect to everything, and you can update it if you want up until the requests. The next feature is basically something new in SP3 release, and that's basically a feature where you can import multiple tool items and mount it to the, in this case, I just show you the example of the revolver, and here we have a new features mount to all to free stations, which we will analyze basically all the free stations and mount all the selected tools. I'll show you later on, this in the real life example. Now, with the newest release, we also add an option to set a default tool assemblies library name. Now, in comparing to the machine tool setup library name, this was always possible in the SolidCAM, and basically it allows you to, once you define, your new CAM part, you already have all your tools set up in your tool table, okay? This is nice option still available, but some of the companies actually like to organize their tool assemblies completely different. For example, for each machine, they would like to set up their holders according to the adapter. Therefore, they will create completely different libraries of assemblies for each machine, okay? And therefore, for example, here I put like the assembly with HSK A63 here. And basically, every time when you create a new CAM part, all your assembly items available in this library will be stored in the storage folder in your CAM part, basically, CAM part toolkit, okay? Now, what you need also to understand, to note that the machine tool setup library and tool assembly library name cannot be, defined both. So you need to choose only one of these, okay? The next feature available here is to set the measurement orientation of your tools. And basically, depend on the turn type, you can measure the tool on the specific spindle orientation, tilting angle, or any indexed position and get the tool offset output and simulation accordingly. So over here on the right side, I just put, the example of the revolver, where in the comparing to the previous versions, to support such a thing, you basically needed to create like a tool holders, a different quota system orientation. But today, with the newest release of the toolkit, you can basically set your machine to the specific machine orientation and measure your tool accordingly. And in the next example, I actually put the example of the spindle turret with the B-axis, where you basically have an option to measure your tool under specific B-axis value or spindle orientation. I'll show you also these things in the example. The next feature that I want to show you is inclined tool nose position, which is kind of filter whether or not your machine is capable to change different tool angles for measured tool offset. And basically on the very bottom, which will be still by default set to yes, your machine is capable to pair one measured orientation to change any of this angle and to receive, the correct tool offset. Many of the machines unfortunately doesn't have this feature, and if it doesn't have this feature, basically you need to set this parameter to no, which will actually allows you only to use particular, let's say, tool orientation and B-axis position, spindle orientation, based on the measured orientation done in the toolkit. The next feature that we are very proud of, is the feature to actually support, completely angular holders, and of course, let's say like this. And the next basically feature that I actually like to mention and that we are very proud of is that we can fully support multi-positional and angular holders. We can basically control any indexed position of the holder. Also for the multi-positional, it is critical, to have this measurement orientation feature that I just mentioned. And finally, that many customers of ours actually requested, to support this indexed holder for the turnings, and here also we can support any different tool type, basically, mounted on this holder. So with that being said, let me just go into an example here. And here what I have here is just simple Milturn project that I didn't run any specific, how's it called? I didn't actually run any operation. Okay, so basically what I'm going to do here, I'll just import, the tools from the library into my lower turret. So as you can see here, nothing I have here. And what I'm going to do, I have prepared the library. Now the library can be, only one. It can be, thousands. Doesn't really matter. For this one, I just choose, for example, from completely different machine. I have some of the tools over here, and what I'm going to do, let me just go back to this one because I name it. So here I have my lower turret here. I will go to my stations. I have here available like roughly about 10 tools, and I'm going to select all of them. And the new feature that is available, I'll just do a right click, mount to lower turret, and here we have mounted the free stations. What you can note here that, for example, the station number 6, it's not selected, therefore also it was not imported as selected, and also 11 and 12 it's not selected either. I can save it. Actually, I can go back. I can go to my machine preview, and this time everything is loaded. Like in a split of the second, you have all set up, right. Now, but imagine that you actually don't want to use this one, but you actually want to add additional one and prepare a completely new machine setup library. So let me go to this one over here. Let me close this and open the preview. So let me go with this one, for example. I like this one, maybe this one. So these two, I can do a right click, lower turret, mount to the free station. He will now mount it to the number 6, 11, and still 12 will be open. So I will leave it as it is for now. And going to the preview, I can see new basically setup that I can just use in my project. This is now easier way, to mount fastly, not only on the revolvers, but also on the linear turret as well. I also mentioned here this default assembly database. You can find it in the working style over here, going to your toolkit. And here you can find, tool assemblies library name. As mentioned, I will just put it on HSK A63 here. And once I do a save and exit, nothing will actually basically change up until I open completely new CAM part. Okay, for this one, it doesn't have any effects. Okay, let me go to another pod. So in this one, I'm just basically going to Toolkit, and I want to show you this feature of measurement orientation. So I will just basically find a tool that I'm actually, this one, for instance. This is a very representative tool. And over here, I have only one cutting point. If I don't change anything, my origin position, if I don't change it here, it will be set here because of its kinematic solution. So if I move this around a little bit and open the machine preview, I can also use this focus tool option if I select the tool. And this is actually my orientation of the tool when it is measured. That's why actually the cutting point that we have here, it's located there. All right, so this is not a real case. You will always, measure this tool under 45 degrees angle at least. Therefore, for making this, cutting point measure it, I will click on this feature over here, measure it orientation. Okay. So I'll click on the measurement orientation. My angle would be -45 in this case. Okay. And this is my measurement orientation. Now this is nice. I like it. And I can actually call this one, you can call it like by the name spindle, that you want to use it, or maybe by the tool offset number or tool index position. It's really up to you. Now, if I want to use the same tool, also for example, for a sub spindle, I can just easily just do a right click at a cutting point, but this time I will use my measurement orientation, put 45 degrees, make a spindle orientation 180, and here I will have another cutting point. As you can see this time, let me just go back to the main spindle. Automatically he will choose a G here for my offset point, the cutting point, and I can change that. So if I go to my point over here, I can go here, I can see it there. So I can just basically change my origin position and switch it to C, which is actually correct for this one. And for second cutting point, for my, let's say, back spindle, I can basically do let's say origin position D. And this would be actually correct in this case. So now I have main spindle, sub spindle, I can use it both. So let me just save and exit. But before actually save and exit, I want to show you also I'll just save it. And I want to show you also angular holders. This is one of the example. What I like here that we really here used, the real cutter here, real end mill with all the flutes. And what I like here, when you click, on the any of the cutting points, you can actually see it in the revolved position. Okay. Also, what you can do, you can set a different, C or A component or A axis. Sorry, they are indexed completely. Okay. So I really like this one. Also, kinematic solution that will be found afterwards in the job. It's everything taken automatically. Okay. Right. So let me just go to this indexed turning tool, which is over here, and I will basically mount it to my upper turret. And this one has a lot of tools. Okay. Also for the thread, I just here play a bit with this. Okay, so as you can see, fully supported. So let me go save this one. Let me go to my facing. And here I already used this tool. Okay, so I can just basically show you the toolpath. The toolpath is nothing special. I'll just go to my host CAD and just show you that you can actually see complete holder, but not only with one tool, but with all tools that are available in that subassembly, let's say so, okay? Another way, I will just go to my tool that we just set it. And here we have a couple, one new feature. As you can see, you can basically select a particular tool item and just accept it. But in the case that you have basically more than one cutting point, SolidCAM will actually not allow you to make it, as there are multiple touching points. So in that case, you need to select the specific one that you want to use in this case. So basically in this case, I will just, I don't want to use this orientation. I want to use this orientation and just save and calculate. Now, here this is the example of using this holder, but as you can see here, you can use any tool angle. So you can basically change it to any angle. If your machine can support this, that's great. If your machine cannot support it, you must use only the one offset that you actually measure it at. And therefore, in this case, I'll just go to my machine and I'm going to go to the controller definition. I'll go to my general parameter, and here there is like inclined tool nose position, and I'll set it to no. Save and exit, and you can note that I only have one available, the one that actually I just selected. That I have actually measured. All right. Let me just back to the presentation. All right. So the next feature that we are very proud of, and also it goes along with the fact of the supporting of the angular holders. The second basically thing is, support any shape for the milling or turning cutters. Okay, like this was like essential for especially for the turning tools, like custom shape cutters, especially for the boring on the mill turn, and of course on the all Swiss type machines. It is essential to have custom shape cutters and to support them. Okay, so we are proud of it to say that we can today, we don't have any limits basically with supporting these tools, and I'm going to show you in one of the example how to do it. I also shown now importing any of the tool components and how to do that, we explain it in the 4 basically videos that with this presentation we'll go along the link, so you can basically click on any of these ones. Okay, but if you want to find it easily, you can also go to the solidcam.com, going to the webinars folder here, and you will find latest webinar. So everything is actually basically located there, where we basically split 2 parts for the milling tool components and 2 parts for the turning tool components. Another option available in SolidCAM Toolkit is to easily manage and exchange holder configurations on your Swiss type blades. Okay, it is not so common, that the Swiss type exchange the holders, but these days there are a lot of machines, very complex axis configuration. It's coming like with a lot of options of holder configurations, and our particular customer required, to have an easily exchanged holder configuration for each of the application that he's machining. And here, as you can see on the very left, this case study is for the Tornos GT26B. Each of these, let's call it turrets here, can be, exchanged. And here in this presentation, I'm just going to show you here how can that be easily done with the toolkit. The next very small feature, but I think it's worth mentioning it, is to set a tooltip position according to the default tooltip offset. Now, for all users of the Swiss type, they know that each of the turret and each tool position basically have the default tool offset position, which in this case is basically on 26 millimeter from this face. Okay. This doesn't mean that tool can be extended only up to this position. It can be more, but the 0 offset, it's set it here, okay? And option that is available, it's actually located over here, and I'm going to show you where I just put, the custom offset, and the tooltips, actually, it's offset according to that station position. And another feature that I would like to mention, it's a calculation of the joint position and orientation based from the 3D model. And if some of you already watched our previous video recordings that we have done online, basically you've seen there that we actually used, the SolidCAM utility to get, the joint orientation. Now, for all of you who doesn't understand, what are the mounting points and joints, so basically each of the components in our library consists of the mounting point and at least about one joint, that, and each of these components will be, will be connected to each of these mounting point and joints. And for instance, here I just put, the example of the custom shaped tools, which can have pretty, not perpendicular orientation of the joint, which is pretty hard to calculate it, from the CAD. And therefore, we actually use SolidCAM utility to get us there. But the problem was that SolidCAM utility is an add-in only for the SolidWorks. Therefore, we create a unique solution within the toolkit, which will allow you, to do the same basically by clicking on this option over here. The last but not least is the new link option to restore a link. Whenever you fix your library, you are able, while you are in the project, to restore the link, and I'm going to show this feature as well in the next example. Okay, so basically let's jump into a toolkit. And over here, let me show you the kinematic of the machine. Let me just make it a bit bigger. So this machine has a lot of turrets here, also including the one with the B-axis here. And this particular one here, the front drilling holder, can be replaceable basically. So the way to do that, I'll just, go to, let me find it here. Yep, it's this one. So when I click it, it's selected, it's over here. So I'll just basically remove it. I will go to my components. I will go to Tornos. Let me find the specific one. Oh, it's this one with the 4 chisel tools here. So I'll just drag and drop, and it's automatically mounted over here. Easy as you can see it. Now, what I would like to do, I can now easily just, just copy the particular tool, just paste it, to that particular position. Just paste. Let's go to another one. I'll just go copy component, and just paste. As you can see, he automatically gets to correct spot. And you can see how easily it is. Right. The next feature that I wanted to show you is the one that you can see it over here. I'll just try to zoom it a little bit. I will show you on this one over here. This particular tool, it's on 26 here from in the X direction. And if I want to change that position, in the past, what you did, you basically change this position over here. And in many cases, this was, this was very difficult, to say, where it will be located, especially if the position was not set here, but if the position was set over here, okay? So it depends from the VMID itself. But today you can basically go to the quick access, and here you will find, this option, set position according to the tooltip offset, where you can basically, according to this point, set your tool, your cutter and the shank itself together automatically. Here you go. I'll just click OK. I'll also show you another example of the mill tool over here. So I'll just add another cutter. This time I'll just put it on the tool 161. Then, as you can see, it is automatically set to the maximum position and to the station position over here. But you can always, change that position and to, put it along the Z in plus or minus direction. All right. Now, as you can see here, I also prepared this boring tool here. As you can see, custom shaped one. And in this position, I'm going to add another one, but also using, some nice options. So what I have prepared, so it's a custom shaped turning tool. And I already prepared it a bit as it consists basically of the cutter itself and the shank itself. And over here, I also create like shank coordinate system together with the insert coordinate system and the joint coordinate system. Now, as you can see here, these two coordinate systems are not parallel at all with the shank coordinate system, and it's kind of hard, to get the orientation properly, of it in the toolkit. Therefore, but of course not anymore. So therefore, I will just now hide it here, and let me just save it as, and I will basically save this project to new folder. I will call it like Q4. This time it will be the STL. I will go to the options. I'll go with the course here. It will be my shank coordinate system. I'll just click OK and do a save. Right. And now I'm going to unhide my cutter. I'm going to go to the save as again. Same folder here, metric, submit Q4, STL. I'm going to go to the options. This time I'll go with define. And I'll change my output coordinate system to insert coordinate system. I'll click OK. And here I'll just add, actually, it's a cutter itself. And I'll save it. I will not close the project, so I will leave it, okay, as we will need it also very soon. I'll open the project. I will go and create the new tool components library. And first I'll create the shank. So I will just jump, make a round shank here. Actually, it doesn't matter which one you use, round or square, as long as you select your 3D model. And I will easily find it there. As you can see, successfully imported. I will go to my connection and set all these to 0. Okay. And now the trick of using this feature is actually to not be in CAM part, but you actually need to open your CAD. So I will just easily jump into this project, into my part here. And this time I'm going to click this and hit calculate the relation between the coordinate system. Now, when you click on this one, Toolkit will basically find all available coordinate system that you predefined. Therefore, my master coordinate system will be shank coordinate system. and my slave coordinate system will be joint one coordinate system. So I want to create a joint. I'll click apply, and you can note that coordinate system is in the correct spot. I'll click OK. And the last thing that I have to do here, I want to make a cutter here as well as a 3D model. I'll just go to the proper folder, just use it there. I don't need to change anything. I just like it. And I just will save this. And we'll call it also Virtual Summit. Q4. Okay, now let's see. Let me go back to our toolkit. And this time I will load my component from just created Virtual Summit Vault file. I want to see where it is, where I want to put it. Let me just find it here. It must be somewhere on the bottom. So it is on my turret BG5 from 510 to 580 in this time. I'll just go and open it. I'll put my shank on 520 just next to this one. As you can see, it's over here. It's automatically, he set it to this tooltip position. I'll just add a profile here. Let me just go over here. I actually needed to set the zeros in the folder, but it's okay. My shank, everything is proper. Of course, I don't want it there. This is not rounded here, shank, so of course it's not proper for this, call it, okay, but just take it here as an example, okay? So let me just jump to mounting here. So I will just move it in the positive Z direction just to make it, you know, roughly into the correct position, and maybe to rotate it 180 degrees, I can do so. Just perfect. In my tool viewer, I would like to set up my cutting point. My cutting point is not right, so I will just, you know, go to my offset and change the origin to this one. That's basically the last step that you need to do in this. I'll just save it. You can note over here. You can note over here that these actually have the links towards it. And what I'm going to do here is I will just intentionally just, you know, close the project. And I will go to my metric folder. And let's think, you know, to, for example, that we actually change the name of this folder, right? So it doesn't exist anymore for, you know, this project that we have just done. As you can see, our Shanken profile is actually marked here as saying, you know, the link is not found, you know, of the file that you can just see it over here. So it's this information is actually quite useful for this, as you can, you know, see which one actually is missing and what is the name of the missing file. So you can now go back here, fix that, and you don't need really to reload everything, you know, you can just do a right click, and here you have this new option of restore link. So I'll just click it, and you can use this tool again. And for the end, I would like to say thank you for your attention. I hope this presentation was useful for you. And also, I would like to invite you to SolidCAM forum, where you can get the latest, you know, the tips and tricks, tech and sales activities done by SolidCAM. Enjoy watching the rest of the presentation and have a great day.